All right, let's look at another item of review. We've got inequalities. So let's first remember, how do we graph inequalities? Here I have x is greater than 2. Now if we look at a number line, what that means is any number bigger than 2 is our answer. So the number 3 would be an answer, the number 4 would be an answer, and so on. So what we do is we're going to have an arrow going to the right because all those numbers are bigger than 2. But we're going to have an open circle because we can't include the 2, just things bigger than 2. On the next one we have x is less than or equal to 2. This time we can include the 2, so we close it. We call this a closed circle. The last one we did is called an open circle. And x is smaller, so we go to the left. Now for the last one, you'll notice that I have the x is on the right side this time and the 7's on the left. And the reason I did that is because I don't want you to get used to doing silly things with rules of the arrow and which way things are pointing as far as which way your arrow should point. When you look at this, you should be saying, okay, x is smaller than. You'll notice that that tip, the small part of the inequality sign, is at the x. So x is smaller than 7. So we're looking at numbers that are smaller than 7. 6, 5, and 4 are smaller than 7. So our arrow should be going to the left. And it's not equal to, so we need to do an open circle. So there would be our graph. Now a couple things I want to talk about. We have 4 is greater than 2. I hope you guys would all agree. If we were to do ourselves one of these, isn't this fancy, balanced scale, we would have 4 things in this bucket and 2 in this bucket, and so hopefully you would agree that this bucket would actually go down because it is heavier. So 4 is greater than 2 because 4 is more than 2, it's heavier than 2. Now we could do things to that 4, like I could say, well, I could add 2, and if I add 2 I'll do it to both sides like we normally do, and we get 6 is greater than 4, and that's still true. 6 is a bigger number than 4. We could subtract 2 from both sides, so take away 2, and so we get 2 is greater than 0, which is also a true thing. 2 is greater than 0. We could multiply. Remember multiplying? Multiplying is just saying that something, it's multiple groups. So if I take and I multiply by 2 on both sides, I'm saying I have a group of 4, now I have 2 groups of 4, so I have 8. And over here I had 2 groups of 2, so now I have 4. And it's still true that 8 is bigger than 4. A bigger group doubled is bigger than a smaller group doubled. Kind of makes sense. I could go ahead and I could divide by 2. So I take that group of 4 and I cut it in half. Take the group of 2 and cut it in half. And it's still true that 2 is greater than 1. The thing that I want to point out, the thing I want you to really understand this year is the negative stuff. And you guys probably remember the rules for negatives. If I was to multiply by negative 2 on both sides, you guys know the rule. We get negative 8 and we get negative 4. But the thing is, negative 8 is not bigger than negative 4. Not bigger than negative 4. That is untrue. And I want you to understand why. If we look at a number line, we have 0, we have 2, and we have 4. Now the rules on a number line is the farther to the right something is, the bigger it is. The farther to the left something is, the smaller it is. Well, if you look at 2 and 4, 4 is to the right, so it is bigger. If I was to take that 2 and make it a negative 2, and take that 4 and make it a negative 4, the number line on the negative side actually switches order. So now the 2 is on the right and the 4 is on the left, because things flip-flop when we go to the negative world. So things that used to be big are now farther to the left, so they're smaller. Things that used to be to the left and smaller are now farther to the right and bigger. And then if we were to take this and move it back over, and take the negative 4 and move it back over, now all of a sudden they're moving from farther to the left, moving to farther to the right. And so when we take and we multiply by a negative, we're changing a positive number, what used to be positive, into a negative number. And not only a negative number, but a bigger negative number, which it puts it farther to the left. and we're taking a number 2 and making it negative, but it was a smaller number in the first place, so it's still going to be smaller when we move it over, and it's important that we're multiplying by a negative 2 on both sides. And the same thing goes for dividing. If you were to divide by a negative and divide by a negative, then it will also flip-flop in which world it is and make it smaller. So you really want to take notes on this and write this down in your notes. When you multiply or divide by an inequality by a negative number, you need to switch the sign. And so the reason we switch the sign is because it flip-flopped what's bigger and what's smaller. But it's only when you multiply or divide. If you're adding or subtracting, do not switch the sign. If you multiply or divide by a positive number, do not switch the sign. It is really important that it has to be negative and that you multiply or divide in order for that to have to happen. So let's look at some examples real quick, and then I think we're done. So let's start with this first one. We're going to solve just like an equation, so I have to get rid of the 8. I add 8 to both sides. We have 5y is less than 20. Divide by 5 on both sides. Now notice I divided by a positive, so I'm not worried about switching the sign. So y is less than 4, and one thing you always have to remember to do is to graph these things. So I put a 4, open circle because it's just less than, and it's saying y is smaller, so I go to the left. Go to the next one on the right here. I subtract 7 from both sides. I have negative 3x is greater than or equal to 21. Divide by negative 3, so look at what I'm doing. When I divide by negative 3 right here, I'm taking a negative and I'm going to be making a positive, so I'm flipping its world. And I'm taking a positive here and I'm changing it to a negative by dividing by a negative, so it'll flip its world. So we actually have to flip the sign. So those cancel out. X is, and now we're going to flip it to less than or equal to negative 7. So we go ahead and graph negative 7. This is going to be a closed circle because that line underneath, and it's saying x is smaller, so we go to the left. And then this problem here. Notice I have x's on both sides. I'm going to move the 7x over, and the reason I'm doing that is because then I have a positive x, and then I don't have to worry about switching the sign. So I have 9 is greater than or equal to 3x minus 12. Now I add 12 to both sides. 21 is greater than 3x. Divide by 3. 7 is greater than or equal to x. Now be careful when you graph this one. Notice that the x is on the other side, so we have to think about it. Notice this little point right here. That's saying that the small part, see this sign right here? We have a small part right here and a big part over here. And so the small part is saying x is small. X is smaller than 7. Those numbers are over here. So we've got a closed circle because of the line underneath, and it's smaller, so it goes to the left. So I lied when I said we were going to be done. We have a problem here, and I really want you guys to look at this problem and talk about this, because I get really annoyed when people can't do this problem, and it's all about the setup. This is one of those where you just need to set it up. You'll see tests on this, whether it's my test or a state test, and you need to be able to set this up. And I have so many people that just try to think it out, whereas the setup really isn't all that bad. So let's first read it. To receive an A, Saki must have at least a 90 average on her last 3 exams. So notice she's taking 3 exams, and we're talking about average. Remember what average means. You add them up and divide by how many there are. Guess what? There's 3. Her average is where S is her final exam score. That doesn't make sense. Okay. Describe the final scores that will give her an A. Okay, I'm guessing something went wrong here, but let's just think about this. So she's taken 3 exams. Oops, sorry. She's taken 3 exams, and she already has a 90. Oh my goodness, I think part of the problem is missing. Huh. All right, so I finally figured it out. There was a little translation that didn't come in. So it's supposed to say To receive an A, Saki must have at least a 90 average on her last 3 exams. So again, we talk about an average being adding up her scores and dividing by how many there are. There are 3 of them, so we're going to divide by 3. Her average is S plus 174 divided by 3. Now let's talk about how they came up with this, because this is something you should be able to come up with. S stands for her final exam score. 174, I'm guessing, would stand for the 2 tests before that, because how do I know it's 2 tests? Because there's a total of 3, because they put a 3 on bottom. So this is what was missing. This is one thing they gave us, but if we were given information like test 1 was this, test 2 was this, test 3 is S, what's the average? We could set this up. S plus, so we add up all our test scores on top, divide by 3. Now they're saying that she wants an A. So we need to finish this off and say, okay, so we have this average over 3, and I want an A, and a 90 gives you an A. So she needs to either get a 90, which would be equal to 90, or she needs to get above a 90. And so there we go. Now let's see here, we need to do our math and solve for S, and then we'll know. So we multiply by 3. That's the first thing I need to do, is get rid of that 3 on the bottom. It's all being divided by 3, so I could just take and multiply by 3. So S plus 174 is greater than or equal to, and if I can do my math right, 270. Subtract 174 from both sides, and S is greater than or equal to, let me see here, I'm going to have to do a little math, sorry, 96. Which means Saki is going to have to get a 96 or better to get the A that she wants. And it looks like it's it. Bye.